Good afternoon and welcome to lecture number 15 in MMVA ZG 522 Total Quality Management. My name is Rajiv Gupta. In today's lecture, we are going to be discussing two topics primarily. The first one is Quality Function Deployment, or QFD. We had introduced briefly QFD in lecture number 14. We will talk a little bit more about it in this lecture. And the second main topic that we will talk about is Failure Mode Effects Analysis, FMEA. We will have two modules devoted to FMEA. One will be like an introduction to FMEA, what it is about, and the second one will be talking about the various steps in FMEA. And as always, we will begin with a recap of our last lecture, which is lecture 14, and we will end with a brief summary of today's lecture. So let's start with a recap of lecture number 14. And in lecture 14, we basically discussed quality by design. And what we said is that traditionally, design was a sequential process, meaning that you had one activity followed by the next. So that means once the designers finished their job, they tossed over the designs to the people in manufacturing or in process planning, and they in turn tossed it over to manufacturing, and so on and so forth. And because of this sequential nature of the design process, there were a lot of gaps in communication. There was a lot of rework involved because each person did their job as though they were the only ones that were involved in the design process, and they could not really take into account the effect or the impact that their efforts would have had on the others who also needed to work with the design. And all of this essentially resulted in a longer product development time and also in much higher cost. And what quality by design was supposed to do is it basically took away this sequential nature of the design process and replaced it by a simultaneous or a concurrent process, whereby all the people who were involved in the design and development process were going to talk together with each other, and with their discussion they would actually come up with a design that met the requirements of all of these people at the same time. By doing this, what you actually did was remove the need for a lot of rework that used to be done when you had, let's say, the design people do their job first and toss it over to the process people, and the process people may have come back and said, no, this is not possible, and so you need to redo the design. But this sort of a thing could now be discussed in face to face between the design and the process people, so that before the design engineers froze their designs, they actually got feedback from the process people so that they could make the changes to the design before they got too detailed in their design itself. And in this, what would you really need to do in order to make the simultaneous or the concurrent engineering process work is to have multidisciplinary teams of people, which could include people from design, from manufacturing, from maintenance, from maybe material handling, as we saw in the last class. There are a number of various constituencies that need to be involved in this process, and by putting them together, and communicating with each other at an early stage, you avoid a lot of unnecessary rework, which is a waste. We also discussed the fact that the teams ideally should be co-located. but it is not necessary that the teams always be co-located, because sometimes it is possible that you can have virtual teams whereby the teams are assigned to their individual departments and physically present in different locations, but they all can communicate virtually, and that also can work, although some face-to-face meetings and communication is still recommended. So that brings us to the end of module number 1.